Okay, so here's another homework problem from homework number 11. It says a corporation must appoint a president, a chief executive officer, chief operating officer, and a chief financial officer. Fancy names. Basically, we're going to have a president, CEO, a COO, and a CFO. Okay, so those are very, very specific positions. It must also appoint a planning committee with 3 different members. There are 13 qualified candidates, and officers can also serve in the committee. So it asks us now to please complete parts A through B. So let's take a look at letter A. It says, how many different ways can the officers be appointed? So that's these 4 guys up here. All right. We are choosing 4 people out of a set of 13. And because basically when you have positions that are being assigned like this, we know that order does matter. So as soon as we see that, we know we have a permutation. Permutations take into account order. So we have a NPR. And just as a quick review, the formula for the permutations is n factorial over n minus r factorial. And the difference between this and the combinations is this is missing the r factorial in the denominator. And that's because we don't want to divide through by the different orders. Here, orders do count. So we have 13 people to choose from. We're going to do a permutation, and we're choosing 4 positions. So the reason this is a permutation is because you could have the 4 people, A, B, C, and D, but they could be in a different order. B could be the president, and C could be the CEO, and A could be the COO, and the D could be the CFO. Or using those exact same letters, it could be A, B, C, D. So you can see that the same 4 people, order does matter, unlike with a combination, which would eliminate all those double ups. So this is going to be a higher number. All right, we are not going to plug this into the formula because we have a calculator that will do it. So go ahead and click 13 into your calculator, then hit your probability button, scroll down to where you have NPR, and then you're going to plug in the number 4, and out will pop 17160. So there are 17,160 ways you can choose these 4 different positions out of a set of 13. So how good are your chances for you and your 3 best friends to get those jobs? They're pretty small, huh? All right, let's move on to letter B. Here we go. How many different ways can the committee be appointed? Well, let's go back up here to the question. It must also appoint a planning committee with 3 different members. Let me grab my pen here. All right, 3 different members on the committee. However, unlike the board with very specific positions, you're just on the committee. Order now does not matter. Order does not matter. You have 3 committee members now, but order doesn't matter. So whether you choose A, B, and C, or C, A, and then B, that should only count as 1 group. So now we do need to divide through by that double up. So this order does not matter now. So just have to remember, when order does not matter, we get the N choose R. It's a combinations problem. The formula is exactly the same as the permutations, except we have N minus R factorial in the denominator, but we also have times that R factorial. That's what gets rid of those double ups or triple ups or all the different combinations with the same letters. Okay, so we have a combination problem, and again, because people on the Board can serve also on the committee. So even if you're the president, you can still be one of the 3 on the committee. So we've got the whole group of 13 to choose from. And this is a combinations. We are going to choose 3 people. So I'm going to go to your calculators again, plug in the number 13, go to your probability button and choose the NCR button. And then you're going to plug in the number 3, and that should pop out with the number 286. Okay. All right. Let's take a look at the last question. C says, what is the probability of randomly selecting the committee members and getting the 3 youngest of the qualified candidates? All right, so first thing we know, like we talked about in class, when it says, what is the probability? Oops, covered right over it. And now we've got to go back to our probability of an event equals that same old formula, number of successes over the total possible outcomes. Okay, so now we're going to have a fraction, a decimal answer. It's a probability question. All right. So what is the probability of randomly selecting the committee members and getting the 3 youngest qualified candidates? All right, well, we've already done the work for the total here. We just did that right up here. This was all the different ways that we can choose the committee members. So we want the number of successes. How many groups of youngest people are there over the total possible outcome? So I'm just going to go ahead and write the 286 right here. All right. Now the question is, how many of them are the 3 youngest? Well, let's say your 3 youngest people are A, B, and C. You got D, E, F, G, so on, all the way 13 people. If your 3 youngest people are A, B, and C, well, how many different ways can you get A, B, and C? Because order doesn't matter in the combinations. It's just one way. There's one way to get A, B, and C, and that's A, B, and C. So real simple. 1 out of 286. And there you go.